Hello and welcome to this Level 6 Mark Periodic Trends question review. This clip designed to take you through the recent periodic trends question we did at college, so you can have a look at how possibly you could have approached it differently if maybe it didn't score as highly as you would have hoped. As with all level questions, you have to read the question carefully to make sure you know what it wants you to do, and in doing so it will often allow your mind to think through to an obvious way in which the answer can be structured. So all sections of the question obviously must be addressed in some way if you're going to have a chance at getting full marks. So let's have a look at the question first and then see if we can put together a plan. So it says the question is about elements in the period 3 to 4 of the periodic table, and it says the table shows the melting points of elements in groups 14 to 17. We know them as group 4 to 7. And it says explain the trend in melting point from silicon to chlorine across period 3, and it says comment with reasons on the similarities and differences in the trends across period 3 and 4. So to address the first question, the trend across period 3 needs to include ideas about structure, forces and bonds, and the energy required to overcome them in order for the structure to melt. So the second part of the question asking you to comment on with reasons on the similarities and differences in trends across period 3 and period 4. So just taking a quick look at the data suggests there is a general decrease in melting point across both periods. But with period 3, silicon has a very high melting point, but in period 4 it's arsenic that has a very high melting point. So if you've got both elements having very high melting points, that could possibly be due to it being giant covalent. We already know that silicon is giant covalent, so could arsenic be giant covalent? Now sticking with period 4, germanium has a lower melting point than silicon, which is what you expect because it's got more shielding. But if you look at arsenic, it's got a higher melting point, much more so than phosphorus. So looking at the similarities, germanium, selenium and bromine have a similar trend compared to period 3 equivalents, whereas arsenic is different. So arsenic stands out, like we just said, as being much greater than phosphorus, as opposed to less. So now we have the makings of a structure for our answer. So it's told us to explain the trend across period 3, and we can say there's a general decrease melting point. The silicon giant covalent structure has many strong covalent bonds and therefore requires energy to break, and some finer details such as phosphorus having 4 atoms in the molecule, sulfur having 8, etc. So sulfur has more stronger London forces, and therefore that requires more energy to overcome them. In terms of similarities between periods 3 and 4, just going back to trend across period 3, phosphorus, sulfur and chlorine are all simple molecular structure. I'd forgotten to put that one in. So for similarities between periods 3 and 4, you'd need to think about germanium, selenium and bromine, all following similar trend, lower melting point than their period 3 equivalent. And differences would be that arsenic has a much higher melting point than period 3. Its equivalent is phosphorus, of course, suggesting arsenic might be a giant covalent structure. So to just finish off, you might want to say something about London forces present in phosphorus require much less energy to overcome than the covalent bonds that will be present in an arsenic giant covalent structure. So I think that probably covers everything that you might need to cover for this particular question. Like I've said before in my videos on leveled questions, that the way I do it isn't the perfect way to do it necessarily. It's just one way of getting the marks. They're quite flexible actually in how they award the marks, but you need to make sure that you make the key points and you structure your answer and you make a logical and reasoned argument as you go through. Okay, so that's it for this one. Thanks a lot again for listening, and until next time, see you soon.